3.1, slope is a rate of change. Okay, rate of change is a change in one quantity relative to the change in another quantity. Okay, so when we talk about rise, like rise is like to go up. Okay, this is the difference between the y values. Okay, and the run, when you run, you go horizontally. This is the difference between the x values. Okay, slope is the steepness of a line. It compares the vertical distance, right, vertical, to the horizontal distance between 2 points. And the slope of a line is equal to rise over run. Okay, so this is usually written with an m. M equals rise over run. So when we talk about a linear relation, this is a relation between two variables that appears as a line, right? So I never actually say straight because every line is straight. Okay, it's implied. If it's not a line, it's a curve. Okay, if it's not straight, it's a curve. When the change in one variable relative to the change in another variable is constant, the result is a line. And a linear relation, in a linear relation, the rate of change and the slope are the same. Example 1, the graph shows the number of squares used in each part of this pattern, and then the points are joined to show the trend. So for example, a lot of times we'll use this as like the pattern number, okay, pattern number. Okay, so number 1, we have 1 square, so 1 comma 1. Pattern number 2, we have 3 squares, so pattern 2 comma 3. Pattern 3, we have 1, 2, 3, 4, 5 squares, so 3 comma 5. Okay, in pattern 4, we have 7 squares, 4 comma 7. Okay, so that's how this like visual representation is shown on the graph. 1, 1, 2, 3, 3, 5, and then 4, 7. Okay, they did extend it one more, that's fine too. So A, determine the rise, okay, so that's going up from point M to N. So we have point M, point N, those are already graphed for us and mapped for us. We want to go vertically up, don't go on a slant, don't go over, it's vertical, right on, like if our points are right on this, like the grid, then it's really easy. Okay, so we're going to count. So we started at 3 and we go 1, 2, 3, 4, 5, 6. So the rise is going to be 6. And then we're here and we want to see what the run is for B. Determine the run. So run is left, right. So we're going to go 1, 2, 3. So calculating the slope of the line, we're going to go rise over run, which I get 6 over 3, which is 2. Okay, and what information about the pattern does the slope give? Okay, so what this means is for each, like I kind of want to say like the next pattern. So for each pattern, there are 2, right? The slope, 2 additional squares, right? Added to that pattern. Okay, example 2, for each, for the linear relation y equals 3x plus 1, we're going to first create a table of values with the x values from -2 to 2. What that means is we go -2, -1, 0, 1, 2. Then determine the rate of change in the y values. So let's go ahead and plug in all of these values. So we have the equation 3x plus 1. So I will sub in 3, -2 plus 1. 3, -1 plus 1, 3, 0 plus 1, 3, 1 plus 1, and 3, 2 plus 1. Okay, going all the way down this column. And now we actually have to equate. So negative 6 plus 1 is 5, negative 3 plus 1 is negative 2, 0 plus 1, 3 plus 1 is 4, and then 6 plus 1 is 7. So for the rate of change, we're actually looking to go up this column. Okay, we see that the difference between the x's is 1. Although a lot of times you'll see it written as delta x, the difference in the x's is 1. So what is the difference in the y's? Well, 7 minus 4 is 3, 4 minus 1 is 3, 1 minus negative 2 is 3. It's kind of like doing the first differences. Negative 2 minus negative 5 is 3. So our slope is our 3 over 1. Our difference in the x's, our difference in the y's over our difference in the x's. The other way that you can see this is right in the equation, in this position here, in y equals mx plus b form, it's the m. Okay, example 3, for the line y equals negative 2x plus 4, first what we're going to do is make a table of values, and then we're going to graph the line. Then we're going to use the graph to find the slope. Okay, so lots of steps here, 3 things that we have to do. So let's go ahead and make the table values, negative 2, negative 1, 0, 1, 2, 3. Okay, and now let's plug those into this equation. So we're going to have the equation y equals negative 2 plus 4. Okay, negative 2, negative 1 plus 4. Negative 2, 0 plus 4. Negative 2, 1 plus 4. And we're going to go all the way down, negative 2, 2 plus 4. And negative 2, 3 plus 4. Okay, so we're going to get the values. That's 4 plus 4 is 8. That's going to be 2 plus 4 is 6. 0 plus 4. And negative 2 plus 4 is going to be 2. We're going to get 0 and then negative 2. So if we take these table of values and we graph them, we're going to get negative 2 comma 8. Negative 1 comma 6. 0 comma 4. 1 comma 2. 2 comma 0, 3 comma negative 2. And we can graph that with a line. Okay, y equals negative 2x plus 4. So taking actually like a look at the equation, we can see that the slope is negative 2. But let's use the graph to actually find the slope. So let's pick 2 random points. I'm going to choose 2 that are like maybe not on the x and y axis, just so we have to do a little bit of work. Okay. And remember, we're going to go rise over run. Okay, so the rise, what I do is I create this triangle. I do a little by little so that I don't go across and I don't go up and down, and this triangle meets very nicely. So the rise is actually a fall. We're actually going down. So we're going to go 1, 2, 3, 4, 5, 6. The rise is going to be the negative 6, and then the run, 1, 2, 3. So we get a slope, negative 6 divided by 3, I get negative 2. Double check that in the equation, and that's correct. Okay, Sam earns $8 an hour babysitting. Make a table of values showing Sam's earnings for up to 5 hours. So I'm going to start with 0 hours, and I'm going to go 0, 1, 2, 3, 4, 5. So here's the thing, like if we're thinking about this regarding like an equation, we're going to go E, which is earnings. Like earnings is going to be $8, 8 times the number of hours worked, and that's it. Okay, she doesn't get a flat fee, she doesn't get like a base pay. So her earnings is going to be, for 0 hours, well, $8 times 0, so that's 0. For 1 hour, it's going to be $8 times 1, right? Which is, 8. And then for 2 hours, it's going to be 8 times 2, which is 16. For 3, 8 times 3, which is 24. 8 times 4, and then 8 times 5. 32, and then 40. Okay, if we're thinking about the rate of change, we're thinking about like the difference in the x's, which we already said like delta x equals, we already stated that these go up by ones, right? We just said, okay, let's go up by ones, starting at 0, and let's work our way up to 5. Okay, so the change in x is 1. Now the rate of change here, we're going to go 40 minus 32, 32 minus 24, 24 minus 16, 16 minus 8, 8 minus 0. Okay, so for all of these, we get 8. Okay, this is our change in y. So if you think about the rise over the run, we're going to have the 8 over 1, which is 8, which makes sense because she earns $8 per hour. Now what we're going to do is we're going to graph Sam's earnings. I'm going to put in a grid. It's going to cover some of this, but that's okay. We don't need this work up here anymore. We can, like, I'm able to say this is like 3, 4, and 5, and that's fine. Okay. You should have this on your paper. So we're going to graph the number, or this is the earnings, and then this is like the pay. Okay, so if she works 0 hours, she gets $0. She works 1 hour, she gets $8. 2 hours, $16. 3 hours, $24. 4 hours, $32. 5 hours, $40. Okay, so this is earnings equals 8 times h. Okay, now find the slope of the line. We kind of did that already, right? We did the rate of change in the y's and then the x's. So we can say rise over run, right? The rise was 8 and the run was 1. 8 over 1, which is 8. And how is the slope related to the rate of change from part B? This is directly delta y. It's technically like the change in y over the change in x, but we know that the change in x is just 1, so we can leave that out. So it's just delta y.